Imagine standing at the edge of a runway. In front of you is a machine that weighs 200 tons. That's heavier than 30 adult elephants, 150 cars, or an entire blue whale. And yet, within seconds, it begins to move. It accelerates, it roars, and then it lifts off the ground. It climbs, it floats. How? How does something so unimaginably heavy leave the Earth and stay in the sky for 12, 15, even 18 hours? Is it brute engine power? Is it wing magic? Is it some secret engineering trick? Or is it pure physics? Today, we're going to break it down step by step and answer one of the most fascinating questions in modern science. How do 200-ton airplanes stay in the air? By the end of this video, you'll understand flight better than 90% of people on Earth. Let's take off. For thousands of years, humans looked at birds and asked, why can they fly and we can't? From ancient Chinese kites to Leonardo da Vinci's flying machine sketches, humanity was obsessed with the sky. But real powered flight didn't happen until 1903. Two bicycle mechanics from Ohio, the Wright brothers, built a machine that flew for 12 seconds. 12 seconds. Today, aircraft fly for 16 hours nonstop across oceans. So what changed? Not magic, not luck, physics. Understanding airflow, pressure, motion, and forces. Flight is not about fighting gravity. It's about balancing forces. And that brings us to the most important concept in aviation. Every airplane in the sky is controlled by four forces. Lift up. Wait. The force pulling everything down. Weight is gravity. Earth pulling the airplane downward. A Boeing 747 at takeoff can weigh around 400 tons when fully loaded with passengers, cargo, and fuel. That's 400,000 kilograms. Gravity is relentless. It never switches off. So how do we fight something that powerful? We don't. We counter it with lift. Lift, the real hero of flight. Lift is the upward force created by wings. And this is where things get fascinating. Airplane wings are not flat. They are curved on top and flatter on the bottom. This shape is called an airfoil. When air flows over the wing, it moves faster over the curved top. It moves slower underneath. According to physics, faster-moving air has lower pressure. Slower-moving air has higher pressure. Higher pressure below, lower pressure above. The result? Upward force. That force is lift. Did you know? A Boeing 747 wing at cruising speed generates enough lift to hold up a small skyscraper. The Bernoulli principle, made simple. Here's the physics idea behind it. Faster air, lower pressure. Slower air, higher pressure. That pressure difference creates lift. But that's only part of the story. There's also Newton's third law. For every action, there is an equal and opposite reaction. Wings push air downward. The air pushes the wings upward. That's lift too. Flight isn't one principle. It's multiple laws working together. Thrust, the forward push. Lift alone isn't enough. The airplane must move forward fast enough for air to flow over the wings. That forward motion is called thrust. Thrust is produced by engines. In jet aircraft, air is sucked in, compressed, mixed with fuel, ignited, exploded out the back. That explosion pushes air backward at extreme speed. The reaction? The plane moves forward. Just like a balloon flying around when you release it. Air shoots backward. Balloon moves forward. Same principle, just far more controlled. Drag, the invisible resistance. Drag is air resistance. It fights motion. The faster the plane goes, the more drag increases. Engineers design airplanes to reduce drag. Smooth fuselage, tapered wings, winglets at the tips, retractable landing gear. Every curve you see on an airplane is there for a reason. It's all about minimizing drag. Step by step, how a 200-ton airplane takes off. Let's put it all together. Step 1, engines power up. Step 2, thrust increases. Step 3, plane accelerates. Step 4, air flows over wings faster. Step 5, lift increases. Step 6, lift equals weight. Step 7, nose lifts. Step 8, plane leaves the ground. And once lift is greater than weight, it climbs. No magic, just physics. Real-life examples. Commercial aircraft, wide wings, optimized for fuel efficiency. cruise at 35,000 feet. Military fighter jets, smaller wings, much higher thrust, designed for speed and maneuverability. Cargo planes, heavy lift capability, massive wing surface area, different missions, same physics. Did you know? A large jet engine can produce over 50,000 pounds of thrust. That's like strapping 30 sports cars together. Stopwatch 27:00, air density and altitude. Airplanes fly best where air is thinner. Why? Less drag. But thinner air means less lift. So wings must move faster. That's why commercial jets cruise around 35,000 feet. It's the sweet spot. Efficient, stable, economical. Common misconceptions. Myth 1. Planes stay up because engines hold them up. False. Engines provide thrust. Wings provide lift. Myth 2. If engines stop, plane drops like a rock. False. Planes glide. Modern airliners can glide for dozens of miles. Myth 3. Heavy planes are harder to fly. Not exactly. Bigger wings generate more lift. The mind-blowing numbers. Average cruise speed, 900 kilometers per hour. Wing area of large jets, over 500 square meters. Fuel burn per hour, thousands of liters. Takeoff speed, around 250 kilometers per hour. And yet, passengers sip coffee calmly inside. That's engineering. Visual explanation for animation section. On-screen sequence suggestion. Show wing cross-section. Animate airflow. Show pressure difference color map. Display lift vector arrow. Show force balance diagram. Show takeoff sequence in slow motion. Keep graphics clean. Minimal text. Big arrows. Turbulence explained. Turbulence feels scary, but it's just uneven airflow. Airplanes are built to flex. Wings bend. That bending prevents braking. In fact, wings are tested to bend upward over 150% of normal limits before certification. Did you know? An airplane wing can flex several meters during flight without damage. How planes stay up for 15 hours. Once cruising, lift equals weight. Thrust equals drag. It becomes a balanced system. Autopilot maintains stability. Computers adjust minor corrections. Pilots monitor systems. The plane is not fighting gravity. It's balancing forces continuously. The beauty of wing design. Modern wings are masterpieces. They flex, twist slightly, adjust flaps for takeoff and landing, change lift characteristics. Flaps increase wing surface area. More surface area equals more lift at lower speeds. That's why planes can take off and land safely. What happens during landing? Reverse process. Reduce thrust. Lift decreases. Plane descends. Landing gear deploys. Spoilers reduce lift further. Brakes engage. Controlled descent. Controlled physics. The bigger picture. Flight is not about defying gravity. It's about understanding it. A 200-ton airplane doesn't ignore gravity. It works with the laws of motion, pressure, and force. And those laws are predictable, reliable, tested millions of times daily across the globe. At this very moment, over 10,000 airplanes are flying, all using the same four forces: lift, weight, thrust, drag. Perfect balance. Conclusion. So next time you board a plane and you feel it lift off, you'll know exactly what's happening. Air speeding up, pressure dropping, lift increasing, forces balancing. No magic, just beautiful physics. And maybe a little human brilliance. If this video changed the way you look at airplanes, hit the like button, subscribe for more deep science documentaries, and comment below. What science mystery should we explore next? How rockets escape Earth, how submarines dive, or how black holes bend space. The sky is not the limit. It's just the beginning.